All right, everybody. Hello. Welcome. Hope you all had a great weekend. Hope you're having a good Monday. Just wanted to start off today with some administrative stuff. Make sure everybody knows what's coming up because we do actually have a big week next week. Not so much this week. This week's pretty chill, I think. Although we are talking about a very important topic today. Next week we kind of got a lot going on though. That's when our next exam is going to be. So exam 2 is 1 week from Thursday. That's when our next exam is going to be. I have already posted the study materials, so just like the last exam, I posted a practice quiz with a bunch of past exam questions, posted a code repository with a bunch of past exam questions, and just like last time, we are going to have a review session in here 1 week from today, focused on the next exam. So that's kind of what's coming up next week. You also have the recursion assignment due next week. We got an sort of a little extra bonus week to work on that. So I would encourage you to take advantage of that. Definitely get started on it sooner rather than later. It is a tricky one. Definitely a tricky one. So get started on it sooner, get it out of the way. And then just as one final reminder, I know I've said this before, but it's so important, I'm going to say it again. The stuff that I'm covering today, Module 7, is not going to be on Exam 2. So while you are studying, do not worry about studying this material for the upcoming exam. It will be on the exam that comes after that. It'll be on Exam 3, which we're taking in December, I believe. So still have a little ways to go before we actually see this material on an exam. Just want to make that absolutely clear so that nobody's confused about what's coming up or what's going to be happening next week. Does anybody have any questions about the schedule, upcoming exam stuff, things like that? Yes?
Will modules 1 and 3 be on exam 2, or is it mostly just going to be
The question was, will modules 1 through 3 be on exam 2? And the answer is no, not directly, in that I'm not going to ask you direct questions about variables or loops or if statements. However, it's very hard to talk about methods and recursion and stuff without using variables and things like that. So, you know, it's there. It's just sort of combined with the other stuff, if that makes sense. Yeah, any other questions that I can address before we hop into today's topic? All right, fantastic. This is a big one. This is a big topic, you all. I mean, honestly, everything that we've been teaching you in this class this entire semester has basically been working up to this point. So all of the stuff that we've taught you up until now is today going to kind of come and merge together into, a very important building block called objects. So objects are the topic of discussion today, and it's so important that for the rest of the semester in this class, we're going to be talking about objects. And if you ever take another computer programming class, another computer science class, chances are they're going to be talking about objects too. They're going to be using objects too. Object-oriented programming is, the most popular style of programming that exists in the world. It is not the only one, and if you continue your programming career, you might run into other programming styles, but object-oriented programming is definitely one of the dominant ones, definitely one of the more commonly used ones. And so today's topic is really just about what the heck are objects, how do we create them, how do we use them, and we're going to be touching on a lot of stuff, like I said, that we've been talking about all the way up in the last classes up until this point. It's kind of all coming together. So let's start off by taking a look at this person class that's in the prep work for today. Also notice too that we're on the final batch of material. So batch 3 contains 7, 8, and 9. Those are the last 3 units of material we're going to be covering in this class. So go ahead and grab the repository for this if you need to. It's the links are on Canvas, or hopefully you did that before class, had a chance to take a look at it. We are looking today at classes. So what is a class? A class defines how objects should behave, what objects should contain. Right? It's a definition. But much like we saw with methods, right? Objects, we define them, but they don't actually do anything for us until we create them and use them. So with methods, we saw that we define a method and then we call it. The same thing's kind of true for our objects. The class is what defines an object. The class is what defines what properties an object has and what methods an object has. And then we actually have to create an object and use it for it to actually do something for us, for it to be effective. We've been using classes the whole semester. In fact, the very first coding example we did had public class, probably hello up at the top, right? Just said hello. That's because Java is somewhat unique in that it requires all of its code to come in a class. Java pretty much requires all code to exist within the context of an object. We've actually kind of been dancing around this a little bit up until this semester, sort of getting closer and closer to this idea of using classes, using objects. But up until now, we haven't really unleashed their full potential. But that's what we're going to be talking about today. We're going to talk about how to write classes and how to use classes. And when I say classes, I really am talking about a definition for an object, right? I'm defining how an object works. So what can an object be? It could be literally anything. You see here we're talking about a person, but we can think of, and now obviously when I say the word object, heavily implies noun, right? So it's going to be a thing. Could be a physical thing. Doesn't actually have to be a physical thing even. As long as it's a noun, we can create an object for it. And every class has two main categories of stuff in it. So you can actually see the first one up here on the screen, instance variables. So one of the first things that I expect to see in any class is a list of instance variables. And this is actually already something that's kind of new, already kind of going off the path a little bit compared to what we've been doing in prior sections of material in this class. You can see that we have 3 instance variables here. They're declared, but not actually set to be anything, right? And that's intentional. That's very much intentional. You can think of these instance variables as the properties of an object, or to make this more explicit, I would say these are the hasas, right? I actually would say this out loud to make sure that these instance variables make sense. A person has a name. Person has an email. Person has a phone number. If you can say it like that and it makes sense, that's an indication that that's a pretty good instance variable for the object that you're working on. We're actually going to get a little bit of practice creating objects in this way later on today. As an example of something that maybe doesn't quite work out so well, if you said, person has, person has a tail or something like that, right? That's obviously not what we would expect a person to have. Or if we say person has a jumping jack, right? Like, well, jumping jack, that's a verb. That's something we do, right? So that's not an instance variable. Things that are actions don't belong here. These are properties. You can think of these almost as like blank items on a form, right? These are placeholder properties. So, we're saying that every person has a name, every person has an email, and every person has a phone number. But obviously, my name, email, and phone number is different than yours, and yours, and yours, and everybody else's. So this code is going to work regardless of what person we're talking about, right? If I look at a person that represents me, then you would see my name, email, address, and phone number in there. If I looked at a person that represents you, you would see your name, email, and phone number in there. And so, how do we do that? How do we actually make a person that represents me or you or somebody else? Well, that leads us to kind of the next important piece that exists within our class, which is the constructor. We're going to talk about constructors quite a bit today. They have a very important role within the class. Constructors are responsible for creating an instance, and that is very much a vocabulary word. Instance is a word that you very much could see coming up on not exam 2, but exam 3, when we get around to taking a test over this material. Constructors create an instance of an object. And the way that constructors do that is by setting the instance variables. So you'll notice that I have 3 instance variables here, name, email, and phone number. My constructor takes in 3 parameters, initial name, initial email, initial phone number, and sets those to the instance variables, right? Constructor, though, I said at the beginning, right? Classes have 2 main categories of things. They have instance variables. What was the other thing that we find in classes? Instance variables and methods. Good. Methods are the other thing that we expect to find in classes. Which one is a constructor? Is that an instance variable or a method? Which category does it fall in? Well, these parentheses are hopefully a good giveaway with the parameters. Constructors are methods, 100%. Constructors are methods. However, they don't necessarily follow the rules that we've been using for methods. If you look at the way this method is defined, we're missing a couple of pieces of information here, right? We're missing some things that we would normally see here. One of the things that we would normally see here is the word static. And actually, we're going to talk about static versus non-static a little bit later on today. What's the other thing that I would normally expect to find in between public and the name of the method? The return type. Good, the return type. So the return type is not listed here either. Actually, that's a good clue. If you see a method that does not have a return type associated with it, so there's no void here, right? There's no double here, right? So if you see a method without a return type associated with it, that's a good chance that it's the constructor. Also notice the name of the constructor is the name of the class. That is not an accident. It is very much intentional as well. So the constructor, the method that is used to create instances of an object, is going to have the same name as the class, and it's not going to have a return type. To understand why it doesn't have a return type, consider what I've been saying the constructor does for us. It creates an instance of an object. So what kind of an object is it creating? It's creating a person object. So the thing that it would be returning would be a person. If I wanted to include a quote-unquote return type for a constructor, it would say public person. Well, that's kind of redundant, right? It's not really necessary. So we just leave it off. We just leave that return type off, and we know that whenever I call the constructor, it's going to return an instance to me of whatever class that is, right? Whatever it says it is. So if I call the person constructor, it makes a person. If I call a car constructor, it makes a car. So on and so forth. Okay, and then down below the constructor, we actually see another method. In fact, there's no limit to how many methods we might find within a class. Practically, there is kind of an upper limit, right? We don't want our classes to become huge. So, you know, after a certain point, we're like, well, maybe we don't need to add any more stuff to this. But the computer's not going to stop you. The computer will let you put as many methods here as you want. Actually, the same thing's true for instance variables as well. You can have as many of them as you want, as many of them as you need. So, you know, one of the questions is, how many do I need? How many instance variables do I need? How many methods do I need? It depends on the problem you're solving. Right? Depends on what you're trying to represent in the computer. There are many things that people can do. We can run marathons. We can, you know, go in the lab and do experiments. We can fly to the moon. If my program isn't interested in those kinds of things, though, I don't need to put them in this class, right? I just need to do whatever I'm interested in doing for my particular program. And so for this one, we're keeping it very, 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 very simple. This is a method called toString, which simply creates a string representation of this object so that we can print it out and read it. So in other words, once I create a person, I want to be able to view the instance variables that that person contains. This is one way that we can accomplish that with the toString method. But also notice, it looks a little bit different. We do have a return type here, but we're still missing that word static. And in fact, that's kind of a recurring theme for today. I'm not going to be writing static methods anymore. Very, very rarely in this class will I write static methods anymore. I am going to be focusing on non-static methods. And non-static methods are good object-oriented programming. When we're using objects, especially, our methods should not be static. So all of the methods that we've been using before now, they were static because we didn't even know what objects were before, right? We didn't talk about objects, didn't need to use them. But now, since we're on the topic of creating and using objects, we're going to keep things non-static with one very, 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 very important exception. This guy right down here. Here's our main method. What's main method do for us again? Starting point. Yeah, the main method's where we begin. That's still true. That has not changed. Right? right? The main method is still the entry point to our program. This is still where we begin. So this is still the very first line of code that will get executed right here, line 27, even though it's all the way towards the bottom of the file, right? The main method is also always going to be static. It's always going to look like this. The computer won't actually find it unless you define it exactly like this. So that's very important. But let's take a look at this main method and kind of see how our objects are being created and used. Line 27. This is actually creating an instance of an object by calling the constructor. And you've actually done this before. We didn't tell you that's what you were doing, but you've done it before. You know, what do we see here that gives us some clues? This new keyword. Where have we seen that before? We saw it with arrays, although there's another. I don't think arrays actually quite qualify. Yeah, I don't think arrays quite qualify as objects in this circumstance. Where's another place we've seen this word? Scanner. There we go. That's the one I was thinking of. Scanners are objects. Scanners are objects. We created them using the constructor. We didn't tell you that's what we were doing, right? We said, here's how you make a scanner. Here's how you use a scanner. Well, this is what we were doing. We were creating an instance of scanner. Just like here, we're creating an instance of a person. So look at what we're doing. This is a variable declaration. So going, you know, I mean, this goes all the way back to week 1. This is the, what is this part of the variable declaration? Starts with a T. It's a type. It's the type. Notice what the type is. It's not double. It's not int, right? It's not string. It's not any of those things. It's person. I'm creating an object that has the type of person. Think about how powerful that is for a second. Person is a class that we wrote. Well, I mean, I kind of wrote it, but I mean, eventually you'll be making your own classes. What are we doing when we make a class? We're actually making a new type. That's what we're doing. We're saying, well, the ints, the doubles, the strings, you know, those are great, but they don't, you know, that's not enough for me to represent what I want to represent. I want to represent a car. I want to represent a tiger. I want to represent, you know, a building, right? So in order to do those things, we need a combination of strings and ints and doubles and other types as well. So this is our way of making a new type. Making a new type that we can then use just like any other type that we've used. So anywhere that I've seen int before, I can now use person. Right? That's very powerful. It's very, very, very powerful. This is just a name, so nothing too crazy there. The word new. The word new, after today, I want that to have a very new meaning, new context for you. That should be an instant red flag that I'm about to call a constructor. When you see that new keyword, unless it's arrays, like I kind of mentioned, are a little bit of a off to the side. But if we're not talking about arrays, and you see that new keyword, we're making an instance of an object. We're calling a constructor to make an instance of an object. What kind of object is it? Well, just look right after the word new. That's what we're making. We're making a new person. So after that, you can see the parameters that are getting plugged in here. We're going to talk a little bit about how this constructor works in more detail in just a second, but you can see I'm passing in the name, the email address, and a phone number. Those get stored within the instance of this object. And I can use this constructor as many times as I want to create as many instances that I want. So if we skip down here to line 31, we can see that I actually call the constructor again to make a second person. This is a distinctly separate instance than the first one that was created. And it has its own values for name, email, and phone number, right? That's how we can tell one person from another, is that they have different values for those very important attributes. Different name, different email, different phone number, right? You know, this is a very, 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 very powerful technique. Using this technique, we could create an instance to represent any person that we can possibly conceive of, real or fake, you know, and then do things with that person in our code. So let's talk about that next part. Once I've called the constructor, once I've created an instance? How do I use that instance? How do I make that instance do something for me? We've actually already seen this too. So if we go back to our scanner idea, right? How do we use the scanner? We'd say in, and then dot, right? And then after the dot comes next something. That's one thing that we can type. That's not the only thing though, right? Can we, what more generally comes after the dot? Next double, next int are examples of, I heard something. It starts with an M? Talked about it 2 weeks ago. Methods. Methods. So this is another big change to how we've been doing things up until this point. Before today, we've been using methods all by themselves, right? This method exists, I'm going to use it, the end. After today, the process is going to shift a little bit. The process now becomes, we need to use a method upon an instance of an object. So we're going to create an instance first by calling the constructor, and then once we have that instance, we can call a method upon that instance using the dot notation that you've seen with the scanner class. So the way that that works is we say the instance name first. Here I'm using P1, followed by a dot, followed by the name of a method that exists within this class. And you can see that there's really only one, for us to choose from here. It's called toString. But if there were other methods, right, in this class, I could use those as well. If I try to use a method that doesn't exist, right, Eclipse is going to say, hey, I don't see that method. There's no method in the person class called hi. You can't do that. So we're actually calling any of the methods that we see in this class. So we're going to call the toString method here. It's going to create a string like this by just kind of stitching together all of the values and then print it out. Print out that string on the very next line. Then we create a second instance, and actually I wanted to show you this little shortcut that you can use with toString. One of the nice things about it is that if you ever try to print out an object directly, print out an instance directly, here you can see I'm just printing out P2, it automatically is going to go look and see, hey, is there a toString method that I can use? And if it finds one, it'll use it. So let me run this code for you and show you kind of what happens when we actually execute this stuff. I might run it through the debugger for you as well. The output is not terribly exciting. It's how we get there that's important. It's the mechanics behind all of this that is important. We can see that first the entry for person 1 gets printed out, and then the entry for person 2 gets printed out. But can we take a look at that in perhaps a little bit more detail? I set a breakpoint here on line 27. We're going to walk through the debugger now and see what happens when we're using the debugger and we're creating objects. So the first line that I'm on, line 27, is going to create that instance P1. And as soon as it does, you can see over here in my variables window, I've got something called P1. And it tells me that the type of it is a person. But if I expand it out, you'll see that it actually contains 3 values within: name, email, name, and phone number. And then you can see the actual values that have been passed in, right, are just sitting there inside of that object. When I call this method upon that instance, it's going to come up here, run this code, create this string, return the string, and stash it in this variable called s. That's all kind of a review from methods a few weeks ago, right? So we can see what that looks like. And there's the string that gets created. That's not actually very useful, but if we click on this, we can see the actual contents of the string, and then it prints it out. This next line is going to create a second instance called P2. So if we step through this, we can see, oh, there's P2, right? And this is actually going to do the same thing as this. This is just a little shortcut. You can't do this with any method besides toString. It's just a little shortcut that we use when using the toString method. But this and this are equivalent as far as the computer is concerned. So once we step through there, we'll see that it automatically calls toString and just prints out the result from that object. But notice that P1 remembers the information that we passed in when we constructed P1, and P2 remembers the information that we passed in when we constructed P2. And when we call the toString method, right, it creates the string depending on which instance is using that method. Here we call it on P1, so it creates this version of the string. Here we use it with P2, so it creates this version of the string. That's actually a lot of very important stuff that I just covered, so I want to pause here before we dive in and do a little bit more detail on these different topics. Does anybody have any questions about what I've discussed so far? Yes? Is there a scope? I love that question. Yes, the question was about scope. We're actually playing around with scope a little bit today with our instance variables. In fact, you may have noticed that the instance variables show up in blue, and you may have noticed that, oh, hey, I'm using the instance variable in this method, and I'm using the instance variable in this method. We actually haven't really been able to do that before. That's actually one of the magic things of using classes, using objects in this way. These instance variables, we would say, do have class level scope, meaning that they can be used anywhere within the class. That's something that we're not able to effectively do with static methods. It's our objects that allow us to do this. That was a great question. Yeah, great question. That also kind of makes objects a little bit more mind-bending, though, for people. A little bit more complicated to understand. That's kind of why we're having this conversation today. Any other questions before we move on to the next part? Question, yeah?
How does it work with the print only working with Is it like a main function?
Yes. Quite literally, it has to be called this. In fact, I can prove it to you if I make a typo or something. Does it matter what's inside of it? Well, it has to return a string, as the name suggests. It has to create a string. Does it matter? No. I mean, in some sense it doesn't, but the standard is that it's going to contain the instance variables. It's going to contain a human-readable version of the object. That's what I would describe it as, right? It does have to be named this specifically, though. Notice that if I make a little typo and I take the G off, right, we get a different result back out. Huh, what does that look like? That looks like when we tried printing out arrays before, doesn't it? And that's what it does when it can't find the toString method. So it's actually a very common thing to do to put a toString method in. And I'll actually talk about how we can do that a little bit later on when we construct our own objects, create our own objects. Alrighty. I'm going to move on and talk a bit more about the constructor. Constructor is a very, 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 very important part of any object. And there's actually, so the last example we saw had one constructor, but there's no limit to how many constructors we can have for a particular object. This will become especially important for us when we talk about our topic next week involving inheritance. But we don't need to worry about that, or not next week, but after the exam. But we don't need to worry about that today. Today we just need to understand that constructors have one role, one job, literally one job. And that is to make sure that all of these instance variables, however many there are, here there's 2, but if, there could be 10. There technically could be 100. I would not want to see 100 instance variables. That's a lot. But technically you could do it. However many there are, the constructor's job is to make sure that every single one of those instance variables has an appropriate value set to it by the time the constructor is finished. That's the constructor's job. That's it. That's all that it needs to do. So there are a couple of different ways you can do that. One way is to just say, I want this to be, equal to some default value, some set value, some constant value, right? Which means that anytime we, construct a car, it would use that default value. In fact, this is what's called the default constructor. A constructor with no parameters in it is called the default constructor. And typically the instance variables will give me some default values. So what are just some, general, generic, made-up values that we can use if we just want some general, generic version of a car? We don't want a specific version of a car. We just want some general generic version of a car. For the purposes of this example, it's saying set the instance variables to the default values of empty string and 2019 for the year. So in order to do that, we would say something like this. We would say model is equal to quote quote and year is equal to 2019. There are two instance variables, and inside of this constructor I have two assignment statements, one for each instance variable. That's going to be true for nearly all of the constructors that we write. Next week inheritance kind of changes that equation a little bit, but we'll talk about that when we get there. So this is called the default constructor. I'll be honest with you, these do have their purpose, but more often than not, at least in this class, we're probably going to be using a constructor that looks something like this. And this is the kind of constructor that is going to allow whoever is making the car to specify exactly what kind of a car they wish to make. So if I use this constructor, I'm getting some generic default car. If I want to make, a 2024 Maserati, then I can plug in, right, Maserati and 2024 in as the parameters and make a car that represents that. Or if I want to make, I drive 20, I don't remember what year it is. I drive a Toyota Highlander, right? I can make a car that represents that, or any car that I can possibly think of. So the other way that we can set our instance variables is not with a constant value, but rather with these input parameters. So for this constructor, I would do something like this. Model equals initial model, and year equals initial year. All constructors are really going to be pretty much this simple. The biggest decisions that you have to make when writing constructors are, where does the right-hand side of the equals, the assignment, come from? Does it come from a parameter? Am I just hard coding it to be some value? Those are really your two options, right? Those are your two main options. Keep in mind, though, that what I'm defining here are constructors. So I will never use both of these constructors at the same time on the same car. Does that make sense? These are each creating cars. So what I'm actually defining here are two different ways that I can construct an instance of a car. And anytime I want to make a car, I will pick one of these two ways, depending on what my goals are, to construct an instance of the car. If I pick this way, then that gives me the ability to tell you what the model and year are. If I pick this way, then I don't have that ability. It just gives me this default one. And if we scroll down to the main method here, the last part of this exercise tells us to create two new car objects. One of them should use the default constructor, and one of them should use this constructor. Well, let's do that. When I'm calling the constructor, we saw this on the last page. First thing I'm going to type when I'm calling a constructor, new. Then I type the name of the constructor or the name of the class, the name of the thing that I'm creating. It's all the same, right? The name of the thing that I'm creating. For the default constructor, that's simple. Default constructor, no parameters, empty parentheses. That's how you know it's the default constructor. There's no parameters. For any other type of constructor, we got to take a look at the parameters and make sure that we pass in values for those. So if I want to make a car representing my Toyota Highlander, I would say new car 2022. I don't know if that's what year it is. Highlander, right? Whoops, what did I do wrong? Oh, I did two things wrong. Somebody tell me one of the two things I did wrong. What did you say the model is? It's in the wrong spot, so I got the order wrong. And then what else did I do wrong? Swap the order, that's still not going to do it. Whoa, hey, that was weird. I set my year as a string, but that's not what type it's expecting. It's expecting an int. Yeah, I double botched it. That's okay. Programmers make mistakes all the time. Important thing is we can look at the mistakes and figure out how to fix them up. Good. All right. So this will create an instance of the car class that has the default values, and this will create an instance of the car class that tries to represent my Toyota that's in the, sitting underneath the Tisch Park right now in the parking garage, right? And if we run the code, we'll see that much like last time, when I print out car 1, I'll see those default values in there, and when I print out car 2, I'll see the values that I chose to use for the car. Oop, here we go. There we go. So blank with the car year 2019, and then here's my Toyota Highlander 2022. Are there any questions about that before I move on to our next topic? All right. Our next topic is something called accessors. So accessors are ways that we use to access data, or specifically access our instance variables within a class. You may have noticed that all of the instance variables that I've shown you so far are marked private. We haven't seen that word before today, right? That's kind of a new one for us, and I haven't really explained what it is yet. Now's the time, though. Now's the time to talk about what it means to mark things private. I'm actually going to go one step farther and say all instance variables, every single instance variable that you create should be marked private, at least for the purposes of this class. When you become a grown-up programmer and are out in the real world, you may find some exceptions, but I don't want to see any instance variables marked public. And there's a very good reason for that, which I would like to work through with you now. In order to do so, let's take a look at a class that represents a student. So, what are the HAZAs for a student? Student has a name, student has an email address, student has an ID. Okay, this is a perfectly workable student class. Here's our constructor that takes in some values. Here's a toString method, here's a main method. Let's assume that I want to use this student object in a different part of my program. Let's assume that this is a big program, right? Maybe I'm trying to make a course management system or something like that. It's a big program. I want to use this student elsewhere in my code. All right, I'm going to make a new class. I'll just call it student tester for now, because I can't think of a better name. I do wish to have a main method. So first thing I'm going to do is I'm going to create a new student. We'll call it first year. And we need to call the student constructor and pass in the appropriate parameters. So what does the student want? It wants a name, an email address, and an ID number. Okay. So I'll just use my information for that just to keep it simple, even though I'm not a first year. I was. Not anymore. Okay. Constructed a student to represent a first year, and then we're gonna, assume that sometime later on, I want to go, hey, what was the ID of that student again? I want to get the ID out of that student. So one thing that you might be tempted to do, based on our discussions, is say first year dot ID, right? Maybe I just want to print it out or something. I would say first year dot ID. This isn't going to work. And the reason that it tells me that it's not going to work is it says the field student.id is not visible. So what does that mean? That means I cannot see what that value is from here. And that really is the definition of what private is. If I mark something as private, that means that I can only access this variable, this instance variable, from within this class. So if I have an instance variable in the student class that is marked private, the only place that I can access this instance variable is within this class. If I try to access the instance variable from somewhere else, like I'm trying to do here, it's going to say you can't do that. That value is private. It's not exposed to you. So, okay, this is a problem. You might think, well, why don't we just make it public then? That seems like it might move us in the right direction. And, that's actually true. it would solve our problem in that I can now print out the ID number. You can see the error went away. As soon as I made that instance variable public, the error went away, and I can actually run this code now. And it'll actually retrieve the ID number that I plugged in for myself, which is 1, and print it out. You might be thinking, okay, that seems like it worked. What's the problem? Why shouldn't we mark instance variables as public? Did you have an idea? Yeah. I mean, you're absolutely right that parallel computing can complicate things a lot, but the answer I'm looking for is even simpler than that. Let's consider that when things are marked public, that is meant very literally in the sense that anybody can access that value. And it's not just for printing. That also lets me do stuff like this. I can just come in whenever I want and say, your ID is now this. And I'm not the only one that can do that. Anybody can do that, right? Anybody can do that. That's a problem. With something like an ID number, that rarely changes, right? Unless there's some kind of weird mistake or something. We don't want these kinds of statements to be allowable. We don't want these kinds of statements to be acceptable statements within our code. They're not acceptable. This is not good programming design. Think about it. There's actually two ways. I've been saying access, access, access. There's actually two ways that we access our instance variables. We either want to look at what that value is, or we want to change what that value is. If it's marked public, I can do both freely whenever I want. And so can you, and so can you, and so can anybody else, right? If it's marked as private, then, that's kind of the opposite case where nobody outside of the class can see this value. Nobody outside of the class can change this value. Well, okay, we're now back to our original problem of, I stopped people from modifying it by marking it private, but I can't access it. So in order to get around this, we're going to create special methods. They're called accessor methods. You might also hear them referred to as getters and setters. Getters are used to examine a piece of data, to look at it. Setters are used to change a piece of data, to set a new value to that instance variable. And we, as programmers, get to choose what getters and setters we wish to include. So, if I have a value like ID, and I want people to be able to see what it is, but I don't want to allow people to change what it is, by marking it private, I can create a getter that allows them to view that value, but I won't create a setter because I don't want them to be able to change it, right? If there are other values that I wish to create getters and setters for, then I can do that as well. In fact, it's very common to create these. Very, very common to create these. I'm going to show you how to do that now. To create a getter for the ID, we'll call it public. Remember, we're not doing static anymore. That's actually our next topic, is static versus not static. I do need a return type. The thing that I'm trying to access is the ID. So the return type is going to match whatever the type is. It's going to be an int. I'll call it getID. It's almost always going to follow that format. GetID, get name, get email. That's why they're called getters. That's why they're called getters. And then inside the body, it's very simple. Return ID. Almost every getter that you come across is going to look similar to this. There are exceptions. There are times when getters need to do more. But for a large chunk of cases, this will do it. The types might change, right? If I was doing the email, then it would be a string instead of an int, right? But otherwise, it would follow the same basic format. And then if we go back to our tester here, well, I can't access the ID this way, but if I type a dot, you'll see that Eclipse shows me all the methods that I have access to, and oh hey, getID, that getter that I just wrote is one of them, and that will tell me what the ID number is, right? I can run this code now and see the ID, but because it's marked private and there's no setter, I can't change the ID. That's big. That's important. For security, for protecting our data, that's huge. This is the proper way to develop your classes, to develop your objects. Every instance variable is marked private. The way that I typically do this is I don't write any getters and setters at first. I add them when I've determined that I need them. So if I'm working on a program, I have a student object, it's like, I really wish I could print out the student's email address right here, but I don't have a getter for that. Okay, now I have a reason to add one, right? Now I have a reason to put that getter in there. If you want to change a value, so I don't think ID is a good one to use a setter for, but email addresses can change, names also can change, right? People can change their names if they want to. So those might be reasonable ones to have setters for. Let me write a setter for you. Just like getters, they're going to follow a pretty similar format. The return type is going to be void. I'm not giving you anything. I'm taking something in and changing a value. I would call it set email. And it's going to take in a parameter. This value represents what we want the email to be, the new email that we wish to store in this object. And then we can simply store that to the instance variable. Almost all setters that you come across, again, there are exceptions, but a good chunk of them are going to follow this kind of a format. And again, just like getters, I leave these off. I do not put them in until I have a demonstrated need, right? Oh, I really wish I could change the student's email at this point. I don't have a way to do that. Let me add in a setter so that I have a way to do that. And then just like we saw with the getters, I would have to call set email in order to change that student's email. Are there any questions about this? This won't be the last time we see this. We're going to get more practice writing these things later. Yeah. The setter? Absolutely. Yeah, I'd be happy to. So if I wanted to change the first year's email, I don't know. We call the getters and setters just like we would call any other method. Instance name dot method name, and then any parameters we need inside of the parentheses. Great question. So from this point onwards, this would be the email address that's inside of this object, not this. This changes it. In fact, just to kind of wrap this up, why don't we prove that? I'm going to make a getter. I'm going to come back to my test here. I'm going to say print out the email address here, use the setter to change the email address, and then we can print out the email address again and see what it looks like after that. So here we go. All right, here's what it looked like before. Then I called this setter, and when I print it out the next time, you can see that it has the value that I passed in from the setter. Any other questions about this before we move on to our next one? Okay, the next topic might honestly be one of the trickiest ones that we talk about for today, but it's also a pretty important one and one that I get asked about quite often. And I can understand why, because we showed you static things. Actually, we showed you static methods to be specific. And now today I'm up here and I'm saying no more static, no more static, no more, except for main, no more static. Get rid of the static things. What's the difference? What is the difference? Well, let's talk about that for a second. Static methods, and actually to be 100% clear, if you open up this person class, you'll see that methods aren't the only things that can be static. Here, we have an example of a static instance variable. So instance variables can be static as well. We don't see this as often as static methods, at least not in my experience, but it does happen. I'm not going to go into static instance variables too much since we've done more with static methods than with static instance variables. But I do think it's important to understand the difference between the two. Static methods and static instance variables, we'd say there is one copy that exists for the class. So I call static methods upon the class. I access static instance variables through the class. Methods, right, non-static methods, we call upon the instance of a class. So think about what that means. To use a static method, I do not have to call a constructor. I do not have to create an instance of an object, right? I do not have to use instance name dot method name. Instead, I would use class name, right? This is a class, not an instance. This is an instance, and this is an instance, but this is a class. Class name dot method name. This is how we use static methods. We've used other static methods. What's another example of a static method that we've used? Well, yeah, main method, but I was thinking of math.random. I didn't have to create an instance of the math class, right? I didn't have to call the math constructor. I don't think there is one. How do you create a math? I don't know, right? I just call the method directly on the class. Compare that to instance methods like toString, like the getters and setters that we've been using. Those are instance methods. Those are non-static methods. I have to call a constructor to create an instance of an object, and then once I've done that, I can call my non-static method upon that object. So non-static methods require an instance. They require an instance of an object to exist in order to execute. And so that's what we've been seeing in all of the other examples before today, right? P2 is an instance. That's a variable containing an instance of the person class. P2 dot toString would call the toString method upon the P2 instance specifically. Another way to think about it, right, is non-static methods are dealing with a very specific thing, whereas static methods are general, right? I don't need an instance. This just works regardless of whatever objects may or may not exist. I know that it's probably still maybe a little fuzzy, maybe still not quite clicking the difference between static and non-static. Just some other things to keep in mind. We've been using instance variables today, like this, private string name, private string email. I cannot access these instance variables from a static method. It's not possible. I cannot access these instance variables from a static method. So, if we actually have another static method in here. Yeah, if we try, right? If we try to come to a static method and say, system.out.println name, print out the name, it's going to say you can't do this. Cannot make a static reference to the non-static field name. That's very, computer science-y lingo for this is a non-static variable, but you're in a static method. You can't do that. Static methods cannot access non-static instance variables. To kind of keep things simple for you, though, I really think, to put in your notes, on exam 2, which is coming up next week, everything's static, right? All the methods static. On exam 3, everything after exam 2, no more static. No more static anything except for main. The end. Will you run into static stuff in other classes? Yeah, maybe, right? But probably not this one. Probably not this one so much. So exam 2 and before, everything's static. Module 7, where we are today, through exam 3, no more static stuff, except for main. We're going to be using instance variables a lot. We're going to be creating instance of classes. That's actually one of the most important things that I want you all to take out of this class is how do we create classes, how do we create instances, and call methods upon them. Very important skill. I know I didn't go through this example in a whole lot of detail. That's somewhat intentional, but if anybody has any questions for me about static versus non-static things, I'm kind of assuming you also read the prep work about it. But if anybody has any questions for me, I would love to answer them before I move on to my next exercise. All right. Our next and last exercise today is sort of a group-ish activity. We're going to make a class from scratch. So this is something that's, kind of intimidating to people when they first start out. So I'm going to pick the topic for us, kind of try and keep us, on the road instead of driving off a cliff. But, if we drive off a cliff, we can learn from that too. We're going to create an object to represent one of my favorite things in the world. We're going to create a cat class. We're going to create a cat to We're going to create a class to represent cats. Okay? And so this is very similar to what we're going to ask you to do in Studio this week. We're going to give you some ideas of objects to create, and we're going to turn you loose. We're going to say, hey, go and create this class that represents this thing. And so when you're doing that, remember there's two things in every class. What's the first thing that I expect to see at the top? Instance variables. And remember, this is the has-as. That's the phrase that I use to make sure my instance variables make sense. And the other thing that I expect to see is methods. And if you're looking for a fancy phrase, there really isn't a super great one, but these are things that my object can do. So what are the verbs that are associated with person or cat? What are the actions that you would expect this to perform? Now, if I'm doing this for a project, a professional project, for example, I have a very clear goal, right? I'm trying to make an app that does X, Y, Z, and the code that I'm going to include here is going to all be focused on accomplishing X, Y, and Z. We're just having a little fun right now. We're just exploring classes and how things work. So I want to kind of ask you all, right? What are some instance variables? What are some has-as for a cat? Cat has a what? Somebody help me out here. Let's come up with a list. A tail, all right. Keep them coming. Age, all right. Breed. Name is a good one. Color.
Hair length.
Hair length. Hair. I'll just write hair. Any other ones? Eye color. Legs. Heard somebody say? I don't know. One semester when I did this, somebody said lives. Cats have 9 lives. I'm like, well, okay. It's true. This is not meant to be a comprehensive list. In fact, we're not going to do all of these today. We probably don't have time, but it's a good list to get us started, right? I'm going to add one to the list too. Cats have, let's see, I would call it a voice or a meow. I don't know. They sound different, right? Like they don't all sound the same. Some cats have different voices than others, right? All right. What are some things that cats can do? What are some verbs that are associated with our fine feline friends? They can walk. They can. What do your cats do? They eat. They sleep. They what? Beg? Oh, play. That's good. What about they shed? Mine do. Oh my gosh. Definitely got a lint roll before I come to work. Yeah. I love that. Yes. Meow is both a noun and a verb, right? They have a voice. They have a meow. And they also meow. They also actively meow. Yes. I love that. Anything else people can think of? There's one that I'm absolutely not going to do, but, when somebody said lives, it's like, well, they go down eventually. It's like, I don't want to think about that. That's a little morbid for me. But yeah, you could do that. That is a thing. You could keep track of your cat's lives. One of my cats likes to sit on the railing of my balcony that's like 2 stories up, and every time she does it, I'm just like, you are making me nervous, but that's what cats do. All right. Now that we've got a good list, I'm not going to do all of this stuff, but we'll do a few of them. I'm going to be a little bit selective here about which ones we want to do. Let's see. I'm going to take off some of the ones that I think might be a bit more tricky for us. Or actually, I don't want to delete them because they're all good suggestions. I just won't add the code for them. All right, let's start with age. Age is a good one. We're making instance variables here. So always, 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 when I'm making instance variables, you already know what I'm going to say, right? We're going to mark it private. I guarantee you, if you ever make instance variables on an exam in this class that aren't private, I'm gonna mark you. Promise you. Promise you. Always, always, always private. Next comes the type. So for age, that seems pretty obvious. I think int is probably appropriate. I don't know of anybody keeping track of their cat's half birthdays or anything like that. I don't know. Maybe you're that kind of cat person. I'm not. But yeah, age is good. Name. This is probably going to be a private string name, right? Hair. I'm going to take this one in a little bit of a different direction, perhaps. I'm going to say private int amount of hair. How much hair do they have? As in, quite literally, like how many hairs are sticking out of their little furry cat body, right? Might seem a little ridiculous, but maybe it'll make sense a little bit later on. And then the last one I'm going to do is this one here. Private string. I'm going to call it voice, I guess. You could call it meow. I think having meow the noun and meow the verb could be a little confusing, so calling it their voice might be a little bit less confusing, right? So here we have 4 instance variables. 4 instance variables, right? All very good instance variables. Could we do these other ones? Yes, absolutely. In fact, I want to point out, while I'm not going to include this one permanently, I could do something like this. Right? We've seen colors before. Colors are objects. Colors are objects. Remember, anytime we have an object, anytime we have a class, that can be used as a type. That's what makes them so, so, so powerful. Think about this one for a second. Nobody suggested this one, but what if I said, this is true, a cat has a mother? How would I represent that? Private cat mom, right? I can do that. I'm inside of the cat class. That means that I've created a cat type, and anywhere that I used types before, I can do that here. That's a little bit, above and beyond where I wanted to go with this particular example. We're going to stick with these 4 instance variables. Now let's move down to the methods. There's actually another very, 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 very important method that I would like to start with that isn't on this list. However, I wouldn't have expected you to say it to me. That every class should contain. It starts with a C. We've talked about it a lot today. Constructor. Constructor. Good. So even though constructor didn't make this list of methods, it's somewhat implied that you're going to need at least one constructor. So let's make a constructor first, and then we'll see if we can do some of these other methods. So public, remember there's no return type here. So I just type the name of the class, which is also the name of the constructor. It's always the same. And now I have to think about, okay, how am I going to set these instance variables? Because that's the role of the constructor, so make sure that all of these instance variables have a value before the constructor is finished. So actually with the first one, we kind of have an interesting conversation. Age, right? There's 2 ways we can do this. I can say int age here and set it like this. Uh-oh. Is this okay? Anybody have any problems? The computer has a problem with this. I'm trying to set this instance variable, but notice that it has the same name as this parameter. Am I allowed to do that? You can, actually. There's nothing stopping me from doing this. The problem is that the computer doesn't know which version I'm talking about. When I say age, it doesn't know that I mean this one. It looks for the closest one that it can find. So when I say age, it sees this parameter and thinks that I'm talking about the parameter for both of these, right? That's what it thinks. There's a way we can distinguish that as a very, 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 very important keyword that starts with a T. This keyword says I'm talking about an instance variable, not just a regular old variable. We would call this a local variable, or actually technically this is a parameter. So if you ever need to refer explicitly to an instance variable, putting this dot is actually a very good thing to do. In fact, I didn't do this on the past examples, but I almost always put this dot out in front when I refer to instance variables, just so I never have any ambiguity. I don't like ambiguity. So I just always automatically do this. Even if I don't have to, just automatically do it. However, let's talk about this instance variable a little bit more. The way that I've got this set right now means that I could create a cat that is 7 years old if I wanted to, right? I just plug in the number 7, and then voila, I now have a cat that's 7 years old. But think about what we're doing. We're creating cats. I'm like bringing a cat into the world for the first time. And I would argue that when a cat comes into the world for the first time, it is not 7, it is 0. I would argue that every single cat that gets created has the same age, and that age is 0, right? So again, this is what I would call more of a design decision, I suppose. But we could do it this way. This way isn't necessarily wrong, but if I wanted to code it the way that I'm describing, where every cat has an age of 0, I can do that as well. I can say, I actually don't need this parameter. I'm going to set this to be 0, and now every cat I create is going to start with an age of 0. Every single one. Remember, there's two ways that we set our instance variables. One is through those parameters, and the other is to say that I'm just going to put a value here, and all instances are going to share that value when they first get created. Will this change later? Yes. This is just the value when it first gets created. Over time, I would expect that value to go up and up and up. This is just the initial value. All right, let's move on to the next parameter. The name. That one, I don't want to tell you what your cat's name is. That one I need you to tell me, right? I need whoever's creating the cat to give it a name. So that one I think is a good parameter. I'm going to pull the name in, and I'll say this.name is equal to the name. The amount of hair. Might seem a little silly why I'm including this one, but I'll set that via parameter as well. And then finally, their voice. I will set with a parameter as well. For these three, right, I don't think that all cats are going to have the same amount of hair. I don't think that all cats are going to have the same name when they're born, right? So for those, I need to accept them as parameters as opposed to the age, which I'm saying all cats are going to start out at age 0. Okay, so there we go. We have successfully created a constructor for our cat. Successfully created a constructor for our cat. Again, just as a reminder, constructor's role is to make sure every instance variable has a value, and we've accomplished that. There's 4 instance variables that we've defined up here, and I've set all 4 of them. I didn't do it the same way for all 4 of them, but that's okay. As long as they all 4 have a value, an acceptable value, that's what matters. That's the important thing. So now let's come down and talk about some of these other methods. I'm going to kind of choose the methods based on the instance variables that we have available to us. So I definitely want to do this meow method right down here. Probably say this one, a meow is a cat's way of saying something. So to me, in my mind, and maybe you disagree, you're welcome to, that just means printing whatever the cat says. That's kind of how I envision this method working. So if all I'm doing is printing whatever the cat says, then I think a good return type would be void, right? And I'll call it meow. If I need to include input parameters here, I can, but I actually think for this method, all we really need to do is, take a look at the, use the instance variables that we have. And since I'm printing, I would say something like this. I would say this.name, so the name of the cat, plus says plus this.voice. So the name of the cat will be substituted in here, and whatever the cat's voice sounds like would be substituted in here whenever the cat decides to meow. Let's do one more method. I'm going to do this one. I kind of had this one in mind, actually. Shedding. All right. I think there's a few different ways we could go with the return type here. I think void is probably fine. Sometimes I get suggested that maybe it should return an int. How much did they shed? It should say, right? How much the shed. I don't know. I think void is probably fine here, but if you want to code it up as an int, please don't let me stop you, right? That's kind of the fun part, the creative part of this, is you can make your objects behave the way you want them to behave. You don't have to make it work the way I want to if you don't want to. So we want our cat to shed. Now we have to be a little bit careful, right? Cats shed a lot, that's true, but they can't shed infinitely, right? If they don't have any hair left, then there's nothing for them to shed. So I think this is worthy of having an if statement. If this dot, amount of hair is greater than 100, then I want to shed 100 hairs, right? And I'll do that by subtracting. If I don't have at least this amount of hair left, then I'm not going to shed any because bald cats look really weird. Google it if you don't believe me. All right. And now we're actually at the point where we can, talk about constructing some cats, making them do some interesting things. So let's do that. I'm going to make a main method down here. And in my main method, I'm going to create a couple of instances of cats, and I'm going to try to create them to represent. I have two cats at home, Lindsay and Saoirse. So I'm going to try and create cats to represent them. Although Saoirse is a hard to spell name. I'm not sure I know how to spell it actually, and it's my cat. That's a little weird, I know. It's actually my wife's cat, to be fair. It's not my cat, but anyway. All right, I'm going to create a cat to represent Lindsay. We'll pass in Lindsay's name. We'll pass in the amount of hair that Lindsay has, which I'll start with 10,000. I don't know if that's accurate, and I haven't counted Lindsay's hair, but we'll assume. And then Lindsay's kind of a quiet cat. She's more of a meow kind of a cat, right? And then I'll make another cat to represent Saoirse. I don't know how to spell this. I have another cat named Franklin, so I'm going to do that because it's easier to spell. I'm going to make Franklin, and he's going to have some hair, maybe not as much as Lindsay. And Franklin, oh my gosh, Franklin wants you to know where he is all the time. He's more of a meow kind of a cat. You know what I'm talking about. So I've got my two instances of the cat class. We now just need to make them do stuff, right? We now just need to make them do stuff, and we're going to do that by calling methods upon these instances. So if I want to make them say something, right, I would say Lindsay dot meow or Franklin dot meow. And if I run the code, it'll hopefully do kind of what you would expect. Right? Lindsay says mew, Franklin says meow. But let's run this through the debugger because I think it's really important to understand, again, how these methods are called. I want to talk about that this keyword a little bit more. We saw that when I ran this code, it very clearly had, Lindsay's information here, right? How does that work? Well, this method call says go here and do this stuff. What is going to be this? When I call this method, the question is, what does this represent? This represents the instance upon which the method is being called. So if I say Lindsay.meow, I run this method, and Lindsay is this. But if I say Franklin.meow, I run the very same method, except this time Franklin is this. And I can actually prove that to you with the debugger. I'm currently paused on line 47. If I step into this method, here I am. Over here on the right, I see this. And if I expand it, you can see that this is the data for Lindsay, right? This is equivalent to Lindsay because that is the instance that the method was called upon. That gets printed out. And then when I call the method again on Franklin, if we examine this, you can see that now I'm looking at the data for Franklin. So this is the keyword that refers to the instance upon which the method is being called. I know that's kind of a complicated topic, but it's a very important one that will, hopefully start to make things a lot more clear once you get some more practice with it. And so yeah, I didn't get a chance to use, the fancy shedding method. In the past, I make my cats have a conversation with each other until Franklin upsets Lindsay and she sheds all of her hair, right? Like that's a story you could tell with these methods, right? Make them talk back and forth and then start making Lindsay shed a bunch. What if I wanted to know how much hair Lindsay has? Can I do that right now? If I wanted to say, hey, how much hair does Lindsay have right now? Or Franklin? Or can I do that right now? What would I need to do? I need an accessor method. Well, let me show you something. This will be the last part of today's topic. Before I type them out, and actually I would recommend that you do type out your accessor methods, your getters and setters, just to kind of get used to them. But let me show you. We use these things so often that actually when I want to create getters and setters, I have Eclipse help me out. So if we go to source, there's an option down here that says generate getters and setters. Right here, generate getters and setters. And then under here, you see all 4 instance variables. So it wants to know which instance variable I'm interested in creating the getter and setter for. That was the amount of hair. And then specifically, if I expand this out, I can select whether I want the getter or the setter or both. I think I just want the getter for right now. So I'll select that one and click generate, and then poof, there it is. No typing required. You are very welcome to use this. This is totally fine, totally reasonable. Any experienced programmer would do it this way. There's no reason for you not to do it that way as well. Though, like I said, I think writing out at least a few just to kind of get used to the idea is a good thing for you to do, since this is all kind of new. All right, we're about out of time, and that was the end of my stuff for you today. Anyway, we covered a lot of ground today, so please review this stuff. Come to studio ready to work, and I'll see you at the exam review next week.